Hello, it's Steve, and it's Geo-rant time. It is March 11th, 2017. Current temperature is 26 degrees Fahrenheit. Traveling back home today. It's Saturday. Today, I want to talk about unconformities, because these are very important in the rock record. Well, what is an unconformity? Simply put, all an unconformity is an interval of missing time in the rock record. That's all it means, okay? There's lots of different types of unconformities. Some are easy to pick out, like angular unconformities. Others are more difficult to pick out, like diastems. This is why the understanding of depositional environments, at least within sedimentary rocks, is important, because understanding depositional environments will help you understand how much time is missing. Assuming there's nothing that can be directly dated. Like in sedimentary rocks, sometimes we have igneous dikes or sills or intrusions in them that can be directly dated. Well, you can't directly date sedimentary rocks. I did that in another Geo-rant. Basically, so how do unconformities form? Well, basically, I mean, if you're driving down, like this road, I'm driving down I-80 right now, heading east. I'm driving over glacial stuff and some older Silurian rocks where they come near the surface from time to time. Now, what I am driving on is technically an unconformity. There's no sediments being deposited. Okay, so this is going to become an unconformity. Well, it already technically is. But I mean, whether or not all the glacial stuff will erode with the Silurian in what amount of time span is anyone's guess, okay? But there are unconformities within a sedimentary sequence. Say you have, typical sedimentary package, a sandstone, a shale, and then a carbonate, like a limestone. That's a typical sedimentary sequence. And usually within this, if you have that complete sequence, if you're looking vertically at a rock record, there's probably no unconformities. There might be diastems. Now, diastems are tiny intervals of missing time. And when I mean tiny intervals, I'm talking in geological time frames here. So a diastem could be anywhere from a few centuries to a few 100,000 years. And like the Silurian rocks around here in northeastern Illinois and northwestern Indiana have a lot of these. And we can pick them out because carbonate rocks, unlike sandstones, are deposited by living things and chemically precipitated out of seawater. Okay? So they're not just weathered, broken down rock. So what happens is you might get a nice sequence of carbonate beds with a lot of little fossils in them, and then all of a sudden you see the surface, and that surface will be pitted. It'll be darker in color, and there's no fossils on it. That's a diastem. Okay, all that means is that the carbonate rocks stopped being deposited for a period of time. And right above it, you might go right back to the fossiliferous, abundant limestones, okay? But that forms what we call hard ground, and it'll have little pits in it. And those are usually 10,000, 50,000 years missing time, somewhere in there. But bigger unconformities, ones that are easier to pick out, like angular unconformities, like if you get sedimentary rocks that are deposited and then say you get a mountain building event, they get bent and folded, and then they're exposed to the surface and they're eroded, well, that folding's still going to be evident because the rocks remaining will be bent, and then you get more sediments packed on top of it. So you'll get like beds going this way and then horizontal beds. The bottom of my hand here is where that unconformity is. And those are real easy to pick out. There's lots of them in Wisconsin, the Upper Peninsula, Ontario. They're just everywhere. So unconformities play a crucial role in the history of the Earth. Sometimes what is not there is just as important as what is there. One of my most favorite unconformities is are the ones between the Precambrian sedimentary rocks, like of the Jacobsville group, and that unconformity with the above-lying Cambrian sandstones. I mean, that's an angular unconformity. It's a small one in most places, but it is there. It's an interesting unconformity because when the mid-continent rift, which will be a Geo-rant for another time, failed, it started getting filled with sediments, most of which were sandstones, in a terrestrial environment. There's some lake deposits like the Nonsuch Shale. But that became exposed to the surface for a brief period of time, probably only about 400 million years or so, but in that time tectonics was still going on. The rift had failed, but compression was happening, so those sediments started getting eroded. And we can tell that even though the Jacobsville group sandstones and the above-lying Cambrian sandstones look a lot alike if you just casually look at them, there's huge differences. For one, the Jacobsville will be redder, it'll be more deformed, and it will not contain any macrofossils, okay? And then all of a sudden you get the Cambrian on top of it, and those sandstones, there's in places conglomeratic at the base, those are still flat-lying pretty much to this day. There hasn't been a lot of tectonics since then. But those sandstones are almost pure quartz aeronites. That means the sand grains are made up of quartz, as where the Jacobsville has a lot of feldspar and lithics in it. Lithics are fragments of rocks that are not quartz, and that are not quartz or feldspars. And so the Cambrian also has, you'll start to see evidence of life, macro life. You'll see some of the sandstones will have like worm burrows in it, and then you get a little higher up in the sequence, still within the Cambrian, and it becomes a carbonate, and you start to actually get invertebrate fossils in it. So that's just my short rant on unconformities. I hope you learned something today, and I hope winter ends soon, because there were a couple days in February there where it was 70 degrees, and now we're back to 20s. But have a good day.